Okay, so on August 21st, first day of real math, today's lesson 1.1. That means module 1, lesson 1, okay? And our learning goal today is to be able to use words, numbers, and pictures to describe how adjacent place values are related. Do you guys notice how this word adjacent is in italics?
Yes.
That's because it's kind of like a vocabulary word. So as I'm saying this and writing things, what do you think you could do in your notebook? Take good notes, right?
Yeah.
Okay, so before we talk about the problem, let's talk about what the word adjacent means. Let's write it down in our notebook. Or maybe you even want to circle it where you wrote your learning goal, and you can write right next to it what adjacent means. What does adjacent mean? What does adjacent mean? Adjacent means right next to each other. Okay, so I love the way I see everyone writing this down in their notebook. Adjacent means right next to each other. So right now, Jaden and Gia are sitting adjacent to each other. Akshay and Kish are sitting adjacent to each other because they're right next to each other. Haley and Emily are not adjacent to each other because they're not next to each other. They're across from each other. Does that make sense? Turn to the person sitting adjacent to you and say, "Hi, adjacent person."
Hi, adjacent person.
Turn to your other adjacent person and say, "Hi, other adjacent person."
Hi, adjacent person.
So now that we know what adjacent means, let's take a look at our learning goal again. What is the question asking? In this case, is there one question or more than one question?
More than one.
Okay, so what you need to write under POTD is what the first question is asking. How many hens does he have in all? So what you would write, how many hens does Farmer Jim have? Okay, you got it. So the second part is how many eggs will Jim collect on Monday? So how many eggs on Monday? So in order to completely finish part 1 of the question, you need to write both of those questions. Number 2 asks you to find the important information you'll need. What information do you need to know in order to figure out how many hens Farmer Jim has? Grant?
So he has 12 hens in each coop.
Okay.
Means, he has 20 coops.
You got it. So we have to write down that he has 12 hens in one coop. And altogether, he has 20 coops. What about to figure out how many eggs he has on Monday? What information do we need? Jaden?
You need to know how many hens there are and how many eggs.
Yeah. We need to know that each hen, one hen, will lay 9 eggs. Okay? So if I do 12 hens in a coop times 20 coops, altogether, how many hens are there?
240 hens.
240 hens. And I love the way, Kish, you remember to label your answer. When you get your first answer, go ahead and put a box around it. We'll always put a box around our answers to show that that's our answer. Now, if we know that there are 240 hens altogether, how can I figure out how many eggs they will lay on Monday? Nithya? I could do 240 times 9. Excellent. And what would I get if I do 240 times 9? I can rename 10 ones as how many tens?
1.
10 ones is the same as 1 10, right? This should be a review from like 2nd grade. 20 ones is the same as how many tens?
2.
Okay. 30 ones is the same as how many tens?
3.
And 90 ones is the same as how many tens?
9.
Okay. Nice. Let's try this one. 100 ones is the same as how many tens?
10.
110 ones is the same as how many tens?
11.
170 ones is the same as how many tens?
17.
And 670 ones is the same as how many tens?
67.
Nice. If I have a dot, one dot in the millions column, go ahead and draw that really quickly. And if I want to change that dot, I want to cross it out and want to rewrite it into the hundred thousands into one adjacent place value to the right, how many dots would I need to draw in the hundred thousands to make it equal to 1 million? 10. Go ahead and draw that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And draw an equal sign like that so you know that they're equal. What we've just drawn is pictured to show that 1 million is equal to 10 hundred thousands. If I wanted to divide those 10 hundred thousands by 10, if I want to put them into 10 groups, 2, 3, 4, 5, 6, 7, 8, 9, 10, how many hundred thousands would be in each group? If I divided these 10 dots into 10 separate groups, I circled each group, how many dots are in each group now? 1. So 1 million divided by 10, is that the same thing as 10 hundred thousands?
Yes.
Divided by 10?
Yes. No.
Is 1 million the same as 10 hundred thousands?
Yes.
Did we say that 1 million is equal to 10 hundred thousands?
Yes.
So is 1 million divided by 10 the same thing as 10 hundred thousands divided by 10? Is it?
No. Yeah. No.
Talk to your table group. Some of you are saying yes, some of you are saying no. Convince each other. If 1 million divided by 10 is the same thing as 10 hundred thousands divided by 10, what is 10 hundred thousands divided by 10? Andrew?
100,000.
You got it. Equals 100,000. Okay, so in your notebook, I know it's hard to see, so I'm going to make... If I have 100,000, that's equal to how many 10,000s? 10. Go ahead and draw that. 3, 4, 5, 6, 7, 8, 9, 10. Now if I divide 100,000 by 10, what do I get? How many 10,000s do I get if I divide this guy by 10?
10.
If I divide 100,000 by 10, do I still get 10 10,000s?
No.
How many 10,000s do I get if I divide this by 10? Akshay? 1 10,000. So in your notebook, I want you to write down that 1 million divided by 10 is equal to 100,000. In your notebook, go ahead and write 100,000 divided by 10 equals 10,000. As we're doing this, what do you guys notice? We're talking about adjacent. As I move from one place value one spot over, does the place value get bigger or smaller? How much smaller?
10 times.
10 times smaller. So if I have thousands and I want to divide it by 10, I'll get 100. Do you guys agree?
Yes.
So as I move to the right, adjacent place values get 10 times smaller. Go ahead and write that in your notebook. That as you move one adjacent place value to the right, the place value gets 10 times smaller. The reason why is because it takes 10 of each unit to the right to make one of the left. So let me ask you a question then. When I move to the right, to the left, are the place values getting bigger or smaller?
Bigger.
And how many times bigger?
10.
Write that down in your notebook. So if we know that it takes 10 of these units, if I have 10 hundreds, that will equal how many thousands? If I have 10 hundreds, that will equal how many thousands? Vic?
1,000.
1,000. Very good. Okay, so we know that those are equal because it'll take 10 of these to make one of the adjacent left ones. Now, what if I have 34 10,000s? What if I have 34 10,000s? How many 100,000s would I have? Sorry, let me ask you a question. Let me ask you a different question. If I have 34 10,000s, how many thousands do I have? Do I have more than 34 or less than 34?
More.
How many more? 10 more. So I have to do 34 times 10, which is, everyone? Okay, so if I have 34 10,000s, can I also say that I have 340 thousands?
Yes.
Yeah. What if I want to move it to this way, to the right? Do I have more or less than 34 10,000s?
Less.
How many times less?
10 times.
10 times less, huh? So what's 10 times? I have to do 34 divided by 10, which would be 3.4. So if I have 34 10,000s, is that the same thing as 3.4 hundred-thousands?
Yeah.
Yeah. So what patterns do you notice about how adjacent place values are related? When I move to the right, it gets 10 times smaller. And when I move it to the left, it gets 10 times bigger. If you didn't write that in your notebook yet, please write it down. If I have 4/10, where do I need to draw the discs? Do I draw them in the ones?
No.
Do I draw them in the tenths?
Yes.
How many discs should I draw in the tenths? 4. So go ahead and draw 4 dots in the tenths. 1, 2, 3, 4. Do you guys agree that this shows 4/10?
Yes.
Okay, draw it in your own workbook too. Now if I want to multiply that 4/10, I want to make it 10 times bigger. Are units getting bigger when I move to the right or to the left?
Left.
Wait,
Right.
hold on. If I want 10 of those, do I need to move it to the right or to the left?
Left. Left. The right.
It's to the left. The right makes it 10 times.
Look back at what we did. As we were saying, when we move it to the left, this place value is 10 times bigger, right?
Yeah.
So am I trying to make it bigger? Yes. So I need to move these 10 times bigger. So it would go 1 spot to the left. So what's 4/10 times 10? 4 ones. Good. Okay. Now what if I have 4/100 times 10? This time, where do I draw the 4 dots? In which column? Hundredths. So this time I have 4/100. 1, 2, 3, 4. And I want to make it 10 times bigger. What's one place value that's 10 times bigger than hundredths? The tenths, right? So I'm going to move these guys over here. And so now I have 4 dots in the what column? Tenths. So the answer is, oops, that's very ugly, 4. The answer is 4/10. Those of you who are taking notes in your notebook and your workbook, you are going to do a good job in math. Those of you who are sitting back and doing nothing, it's going to be hard for you to learn this concept. Now, what if I have this in black? I have 4/100, so I'm going to draw 4/100. 1, 2, 3, 4. And I'm going to multiply it by 100. Is 100 the same thing as 10 times 10?
Yeah. Yes.
So if I'm going to multiply these by 10, I'm going to move it 1 spot over, right? And then I will have 4 whats? Tenths. But am I done?
No.
I have to move it 1 more time over, and now I have 4 whats? Ones. So what's 4/100 times 100? 4. Okay. So do you see how when we're multiplying by 10, we move it 1 place value over to the left? Do you guys see that?
Yeah.
Nice.